Okay, Mrs. Stanley here to get you started on number 124. Reading the question first, it says, a ship takes off from the port traveling due west. So we're going due west. Remember your compass arrows. This is north, east, south, west. So if we're headed due west, sorry, there's a plane flying over. Hopefully you can hear me fine. We're headed due west. That means we're going this way. Pretend this is a straight line. And they're going 14 miles this direction. So this is our starting point, and they've come 14 miles. Then it says, after 14 miles, the captain changes course to north 24 degrees west. So the captain is headed west, and he suddenly decides to start going northwest. The thing that you need to remember is that there is an imaginary line that's like our point of reference. That phrasing came from Miss Portum. It's a good way to think of it. This imaginary line that I've drawn in orange is always there, and it's vertical. It's basically the north-south part of what we think of on a compass. And so this is where we're starting from, and north is going up, south would be down. So he's coming up and then headed to the west. That's this way. This angle right here is the angle that's 24 degrees. So sometimes I think the confusion is that you want to make your angle from where they were going as if it's here. That's incorrect because we're doing it based on this standard point of reference. Okay, so this is the angle that we're looking at, 24 degrees. And then the question says, the boat travels 6 miles on the new route before dropping the anchor. So this side right here is 6 miles. And here he dropped anchor. If you don't know, dropping an anchor means that it's basically a giant metal thing that weighs a lot and will catch onto things in the bottom and make it where the boat won't drift with the flow of the water. It will just keep the boat in a relatively steady position. So then it says, how far is the ship from the port? Remember, the port is here where we started, and the ship has dropped anchor here. So hopefully you can imagine this line connecting here, and that is the line that they're asking you. That would be our X. So you've got 24 degree angle right here, and then see what other information you have. But you do have two sides in one angle. So you have to decide, are we using law of sines or law of cosines in order to find this missing side? So that's for 124. Hopefully that's enough to get you going. And then on number 125, let's read that. It says, Rob has a triangular garden with sides measuring 6 feet, 10 feet, and 13 feet. So we can just draw a triangle. 6 feet, 10 feet, 13 feet. Now, just to be clear, do not confuse that this is 90 degrees. I realize I drew a triangle. It kind of looks like 90 degrees, but that was completely unintentional. We can't use information that wasn't given to us. So the fact that that's how I randomly drew my triangle does not imply that it's a right angle, okay? So here I've sort of fixed it, but you still might glance at that and think it's 90 degrees. You weren't told he's got a right angle in his garden, so we don't know that. If he wants to cover the entire garden and each bag of mulch covers 8 square feet, how many bags will he need? So what do we actually need to know here? If you remember, the area of a triangle is 1/2 the base times the height. But in order to have the height, you would need a right angle from the base. So for example, if you knew this length that I've drawn in pink, you could use that as a height, and then the 10 would be the base. We don't have that. And I'm actually thinking that we didn't do this part in class, but the first thing to notice is that you don't have any angles. They've only given us the 3 sides. And if you remember, one of the law of cosine or law of sines can be done with 3 sides. So I will leave you that information, and actually you have an image here from the answer key so you can tell what they used. But think that through before you look. Which one would it be? If you have all 3 sides, you can find an angle. And then there's a formula right here. It's an alternate way to find the area of a triangle. If you don't know the base times the height, you can use this formula, and you'll notice it's 1/2 this side and this side, and then the sine of the angle. That is the sine of the angle with the 6 and 10. So that's one way to do it. And like I said, I'm pretty sure we didn't actually do that in class this year, but still a fun way for you to see how it can be useful to use trigonometric functions to find the area of a triangle. And since you have the formula right here, it's not too bad. But the main thing is, can you find the angle based on law of sines or cosines?